During this segment, we will look at quadratic functions and their graphs. Now, don't forget when I use the word function, that means when I graph that function, it will pass the vertical line test. So just keep that in mind. Recall that earlier we did graph the function f of x equals x squared, or if you'd like, y equals x squared. But notice that this is a function because this passes the vertical line test. Now, in general, we will be looking at quadratic functions. What is a definition of a quadratic function? It is one that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and of course a is not equal to 0. We will be graphing by using shifting and reflecting techniques. If you did cover an earlier section on shifting and reflecting, this will just be an application of what we looked at earlier. Let's recall a few things about the graph of a quadratic function. Its shape is given a special name called a parabola. Since this parabola is opening upward, this lowest point is given a special name called the vertex. Now, if you notice, this is a sketch, but supposedly this is what we call symmetric about this y-axis. And the y-axis is called the axis of symmetry. Now, what does it mean to be symmetric about, in this case, the y-axis? It means that, for example, if I were able to fold this along the y-axis, these two pieces would coincide. So that's what I mean by the axis of symmetry. So in general, that is the graph of f of x equals x squared. By the way, if the coefficient of x squared, of course here it's 1, if it's positive, this parabola opens upward. If it's negative, the parabola opens downward. And now let's look at some shifting and reflecting, and let's continue graphing quadratic functions. So everything that we graph will pass the vertical line test. Let's look at the following. Graphing the parabola defined by f of x equals x squared plus k. If k is positive, the graph of f of x equals x squared plus k is the graph of y equals x squared shifted upward k units. If k is negative, the graph of f of x equals x squared plus k is the graph of y equals x squared shifted downward the absolute value of k units. The vertex is 0k, and the axis of symmetry is the y-axis. Now that last sentence will naturally follow if we just shift correctly. Notice I have this function h of x equals x squared plus 5. So the general shape, because it's x squared plus some constant, the general shape is a parabola, but it is moved upward 5 units. So since it's moved upward 5 units, instead of the vertex being at 0, 0, if I move that parabola upward 5 units, 1, 2, 3, 4, 5, the vertex is now right here. The shape is exactly the same, although I won't be able to show a lot of it on my rectangular coordinate system. That is the graph of h of x equals x squared plus 5. The vertex is 0, 5. Just as I mentioned, it would be 0, comma, k. And what is the axis of symmetry? You can look and see the axis of symmetry. It is the y-axis. Now let's continue working with this. Let's compare this, say, with another function. Now this is the function what we called h of x, which is x squared plus 5. Let's compare that with f of x, which is x squared minus 1. This is a parabola. It is a function. It passes the vertical line test. But what movement does this cause, the minus 1, tacked on to the x squared. Instead of the vertex being at 0, 0, now you move the parabola down 1 unit. It's as simple as that right now. So move the parabola down 1 unit. Here is now the vertex, and it's the exact same shape as before. So just draw in. We are sketching right now. Drawing that general shape. There is the graph of f of x. What is the vertex? Well, the vertex is 0, -1, and notice that the axis of symmetry is still the y-axis. So there is what causes shiftings up and down, or upward and downward. Now let's talk about shifting to the left and to the right. Let's look at the following. Graphing the parabola defined by f of x equals x minus h in parentheses squared. So notice this time that h is not tacked on past the x squared, it's part of that squared function. If h is positive, the graph of f of x equals x minus h quantity squared is the graph of y equals x squared shifted to the right h units. If h is negative, the graph of f of x equals x minus h quantity squared is the graph of y equal x squared shifted to the left, the absolute value of h units. Now you'll see this will follow naturally. The vertex is h, 0, and the axis of symmetry is the vertical line x equals h. Keep these things in mind so you'll be able to recognize what type of movement. Notice here, this is not x squared and then plus 2. The plus 2 is not tacked on after the squared variable. Here, it's part of what is being squared. So this does represent a movement to the left or to the right. It might help you to think that if it's a movement upward or downward, you do exactly what the plus k says. If it's plus 1, you move up 1. If it's minus 2, you move down 2. Here, you do the opposite. Instead of plus 2 meaning 2 to the right, it actually means 2 to the left. So here, the movement is, instead of the vertex being at 0, 0, this causes a movement of 2 units to the left. So now my vertex is right here at -2, 0. It still opens upward and we're still sketching. So basically just sketch the general shape of this graph. And that's all I'll do. I'll sketch the general shape of this graph and try and make it look symmetric. I hope so. This is the vertex, but you'll know what the vertex is just by how you shifted the parabola. Now, by the way, you can also probably just see that as long as I sketched it so that you can notice, here is now the axis of symmetry. And what is the graph of that vertical line? Remember, every vertical line, its equation is of the form x equals c. And so in this case, this is x equals, what is the x value here? -2. So those things follow naturally. They're shifting left and right. Combine these shiftings. Let's look at the following. Graphing the parabola defined by f of x equals x minus h quantity squared plus k. The parabola has the same shape as y equals x squared. The vertex is hk, and the axis of symmetry is the vertical line x equals h. Everything will just follow if you follow those shiftings. Remember what this causes or what happens to the vertex as you graph. This means a movement of 2 units to the right, 5 units up. So instead of the vertex being at 0, 0, it moves 2 units to the right, 5 units up, and here is the vertex. The vertex is at 2, 5. 2, 5. It just opens upward and has the same exact shape as that first parabola that I graphed, f of x equal x squared. So just sketch in. That's all we're doing right now is sketching graphs of parabolas. Here is the vertex. What is the axis of symmetry? It's the vertical line that goes right through the vertex. And so what is the equation of this? It's x equals the x value of the vertex. This is the graph then, the sketch of f of x equal x minus 2 quantity squared plus 5. See what happens to cause distortions of the shape of the parabola. Let's look at the following. Graphing the parabola defined by f of x equals ax squared. If a is positive, the parabola opens upward like we talked about earlier, and if a is negative, the parabola opens downward. Now here's a little bit more about the shape. If the absolute value of a is greater than 1, the graph of the parabola is narrower than the graph of y equals x squared. If the absolute value of a is less than 1, the graph of the parabola is wider than the graph of y equals x squared. We will put all of that together in just a moment, but let's look simply at this function, g of x equals negative x squared. Now you know what the graph of h of x or f of x or g of x equals x squared looks like. It's a parabola opening upward, vertex 0, 0. This negative, because a is essentially negative 1, the parabola opens downward, and the shape is exactly the same except reflected across the x-axis. Now, by the way, as we graph all of these parabolas, all of these quadratic functions, when in doubt, you can draw a table and come up with ordered pair solutions. We're just looking at shortcuts in graphing quadratic functions. But when in doubt, it is certainly true that what we're trying to graph are ordered pair solutions of the function. So let's look at the graph of g of x equals negative x squared. The vertex is still at 0, 0. This negative just causes the parabola to open downward, but the shape is exactly the same. And again, please try and imagine that this is symmetric. There is my vertex at 0, 0. What is the axis of symmetry? It's going to be for quadratic functions. It's always x equals the x value of the vertex. So here, the axis of symmetry is the y-axis. And what is the graph of the y-axis? It's x equals the x value of the vertex, x equals 0. All of this together, and let's look at the following. This is in general the graph of a quadratic function. The graph of a quadratic function written in the form f of x equals a, x minus h quantity squared plus k is a parabola with vertex HK. If A is greater than 0, the parabola opens upward. If A is less than 0, the parabola opens downward. And the axis of symmetry is the line whose equation is x equals, notice that h? The h is the x value of the vertex, just as I mentioned a moment ago. So let's try and put it all together, and let's sketch the graph of this quadratic function. Its graph is a parabola. If you'd like, you can think of this in two ways. You can think of this as shifting, and this is the parabola shifted 3 units to the left and then 1 unit up. Or if you'd like, you can go directly to the vertex. The vertex has coordinates the opposite of this. So -3, that is the x value of the vertex, and then whatever that is, in this case, 1 as the y value. So let's now graph our vertex, -3, 1, and then you need to look at the value of A. Is A positive or negative? It's negative, that means it opens downward. Now, what happens to the 3? What does the 3 cause? Remember the absolute value of A, if it is greater than 1, which it is in this case, it causes the look of the parabola to be narrower, a little bit narrower. It kind of stretches the parabola a little bit, the -3, so it looks a little more narrow. Let's go ahead and then sketch, and that's all we're doing is sketching. I'm going to sketch a parabola opening downward and narrower than usual. There you go. And hopefully that looks like a function. Remember, everything that we are graphing is a function, so it passes the vertical line test. There we have it. My vertex has coordinates -3, 1. Let me go ahead and sketch in the axis of symmetry. And here is a sketch of the axis of symmetry, and you be thinking about the equation of the axis of symmetry. It has equation x equals the x value of the vertex, in this case, -3. So there we have it. Now let's go ahead and do this again. Let's graph one more function. Make sure you're comfortable with this. Let's suppose we have, let's use h of x again, equals 10 times x plus 4 quantity squared minus 6. Let's go straight to the vertex of this parabola. The vertex is the opposite of that number, -4, that's the x value, and then whatever that is, -6, there is the vertex. So now let's sketch the vertex, -4, -6. Looks right there. Now look at A and tell me if this parabola opens upward or downward. Because A is positive, it opens upward. What else do we know? The absolute value of A is greater than 1, so the appearance is narrower. All right, so I'm going to sketch it in and make it narrower, but it is a parabola. And be very, very careful because it does need to pass the vertical line test. So kind of try and make sure it does. Mine's a little wiggly, but you get the idea. And then what is the graph of the axis of symmetry? Let's graph that axis of symmetry, and you be thinking about the equation of this graph, the axis of symmetry. Remember I told you it will each time have equation x equals the x value of the vertex. So the x value of the vertex is -4. This vertical line has equation x equals -4. The vertex has coordinates -4, -6. And this is a function. It does pass the vertical line test. All right, this time practice graphing quadratic functions.